All right, let's get going. So I'm going to start us off with a breakout. I'm going to pop this into Slack and go from there. You've got 3 minutes for this one. Okay, that's about time. I don't see a whole lot of answers yet. I'm going to give a little bit more time for this, but I mean, anytime you feel like you're done with your answer, feel free to just put it in there. We'll give just another minute for this one. Okay, cool. We're going to do another breakout. Feel free to just get your answers for this one in. I'll give you a minute just to get in your answers, get in whatever you've got. And shoot, let me paste in a solution. Just do a screenshot of the solution. Oops. Okay, there's a solution, and we're gonna do another breakout. Which will be this one here. Okay, cool. Getting a lot of answers coming in. We're gonna move on, but please feel free to put in whatever answer you've got at this point. And we'll go from there. So a couple orders of business. I'm noticing there's a few folks who are struggling with Slack, and some people have told me, and some people haven't. And that's, or presumably, I assume maybe some of you are struggling with it and haven't yet, and maybe I don't know about it. So I do want to go over a few things about how Slack works. Since things are recorded, I can't really show Slack on the recording. So I want to go over those things after class. So if it helps right now, let me look at this. If you want to find the class thread, it is at the very bottom of the post that I made with the class link and the slide decks. At the very bottom of that, there's a little section that just a kind of thin little section that's got some people's icons, or little profile icons, Slack profile icons there, and currently it says 76 replies. So if that helps you find it, that's where it is. If you click on that, it'll open up a little sidebar on the right-hand side, and that's the thread. That little sidebar is the thread. That's what I'll be monitoring throughout the whole, while I'm teaching. So when I ask you to paste something in, or if you want to ask me a question, something like that, that's where we want you to do it. No worries. I'm less worried about this than it might seem. I don't mean to put anybody on the spot. Like, don't feel bad. Slack is a non-trivial program and it takes a little bit of learning, and there's a few little tricks. So I have a few other tricks that I want to go over to kind of make Slack a little more powerful and a little more useful, and I'm going to talk about those probably at the end of the class. I might mention them in a little bit here, but I'll talk about them at the end of class, and so we can do like a short 5-10 minute Slack workshop at the end of class, and it won't be on the recording. So if you're, I suppose I should mention this, if you're watching this on the recording, feel free to get my attention some way through Slack, and I will help you out if you need additional support with learning Slack. All right, cool. Let's get into some things that have to do with Python. There we go. Oops. I forgot to start my file watcher. Let's just do a quick test here. Just blow these away. Good. If you wonder why I do that, by the way, like whenever I start up my terminal and I just like print hello and run it real quick, it's called a sanity check. Just make sure everything's running, that when I run my code, I'm actually going to get output. It's just a good habit to get into. Make sure that your environment is doing something before you try, before you need it to do something, you make sure everything's working right. Okay, cool. So I want to go over a few concepts before we really dive into today's material. Today's material is mostly going to be on variables and control flow logic. We're going to get into writing some dynamic code, but I want to cover a few things real quick. So there's something that I like to do, and I kind of call an overview. I think about this as an overview of kind of programming, like learning any programming language. But this is, I mean this to be specific to Python as well. So when you're learning any programming language, if you're really new to this, I know it can seem really intimidating. It's my goal personally, really, to make this material to make this material as accessible as possible, and approachable. So I definitely felt intimidated when I was first learning, but I stuck with it, and now that I'm comfortable in Python and a few other languages, I look at it and I'm like, well, there's not as much going on in terms of learning how to just do like algorithmic problem solving in a programming language. There's not as much going on, but languages are complicated. It's just a matter of which things do you focus your attention on when you're starting. Like, how do you get, what should your goal be? And the way that our material is oriented and the way that my teaching style is oriented is around, you'll hear me kind of phrase it like this, around like getting you all to the point where you can do like algorithmic problem solving. You have a complete, if minimal, set of tools. This is not going to be, we're not going to teach everything there is to know about Python in this course, but the goal is that we're going to cover a little bit of everything, and enough that you can get off the ground and running and like start doing meaningful problem solving with the language. You'll have a, like I said, you'll have a complete set of tools. So I think about this as covering a complete set of tools. So some things we don't really dive into deeply. Some of you may have heard of object-oriented programming. I used to have a lecture on classes and objects in Python, and actually cut it recently, although I may give that lecture again in study hall if people are interested. So we're not going to go over object-oriented programming. We're kind of going to mention it, but things like object-oriented programming are paradigms. So they allow you to do something a certain way, not just do something, right? So the paradigm that we're operating with in this class is usually called procedural or imperative programming, and I like it just because it involves a rather minimal set of pretty straightforward tools, and it's a good jumping off point when you go learn another formal paradigm like functional programming or object-oriented programming. It's a good foundation to have. So anyways, getting into the overview, when I'm approaching, and I use this schema basically to go, anytime I want to go learn a different language, I use these steps. And if you get good at it, I've picked up languages in an evening or 3, and I assure you I'm not a genius at this. It's just, once you learn one language, the ideas really do transfer pretty well into a lot of other programming languages. So what we're going to cover topically is going to be data types. You want to have a good understanding of what types of data your language supports and how to work with each of those types. What's the utility of this type? When would I use it? How can I change it into a different type? Can I change it into a different type? What are the rules about casting from one type to another? Is this type mutable or immutable? And we'll kind of cover the idea of mutability later. So understanding your data types, knowing when and how to employ each one, that's where a lot of the work is. It's a fairly straightforward idea, but it's sort of, I think about it like with any language, I think about this as like vocabulary building. If you think about, if any of you are bilingual or have experience learning another natural language, you might think about like there's the aspect of a language that is structural in terms of its grammar and word order, idioms, things like that. And then there's an aspect of it that involves some memorization, that involves just knowing what the words are, and that's vocabulary building. So I really think of data types as being the part of learning a programming language that is like vocabulary building. There's a number, I won't say a lot, but there's a number of small things that you just kind of memorize through experience and through doing it. So I'm not gonna lie, there's some memorization involved, and that's kind of where it is. But if you know another natural language, for example, I would say any other natural language is, I think, objectively more complicated and more just bigger. I mean, the vocabulary of any natural language is bigger than any programming language. So not to worry, this is much more bite-sized than learning a whole, like, learning Spanish or German or any, Chinese or another natural language. So don't be intimidating. Okay, so that's one topic. We're going to cover data types. We're going to want to have a solid understanding of the data types in Python. You want to have a solid understanding of abstractions. Now, in terms of just performing an algorithmic process, abstractions don't necessarily make something more possible, but they make things easier, right? An abstraction is what you do when you take a complicated idea and you wrap it up in a simple idea, right? So, for example, instead of saying, give me the rolling, or give me the product of n times every number between n and 2, we would just say, give me what's the factorial of n. You know, that would be an example just in English of an abstraction, right? So rather than describing the process of how to do a factorial, you just say the word factorial, right? And we do something very similar with abstractions in Python. So I'll give you an example of that. And we'll get into writing functions in the next lesson, but I'll give you a little window into what writing functions looks like. So imagine I had, you know, numbers in my code base, and we'll just say I have n, m, o, and p, and we'll say n is 4, m is 5, o is 3, p is 8. So we've got a few numbers. So if I needed to do the factorial of each of these numbers in my program, you know, I could do something like, let's say n factorial equals 1, and say for I in range 2 to n, we'll say n factorial times gets I, and we can print n factorial, right? So this isn't terribly a lot of code. And I know this is, you know, we're looking at some things that we haven't talked about yet, but I want to give you a little window into like what we're going to be doing in a few days. And, you know, you'll kind of see this. It doesn't have to make perfect sense right now. It'll make sense in a little bit. So rather than saying, okay, so this is how I would do a factorial algorithm every time I wanted to do factorial, and if I want to do factorial of m, you know, we could do factorial of, factorial of m like that, and we'll go up to m here, right? So I have I have to copy this whole thing. It's kind of a pain, and we'll do O. It's kind of a lot. I'm kind of trying to rush through this. I feel like I'm being sloppy. I forgot something. I got to change this to O. See? It's error prone, right? So it would be nice if I could just like save this algorithm and just write it once and just give that algorithm a number to give me the factorial of, right? So these will all work, you know, so technically these will work, but it would be nice that instead of just having to write out this algorithm every single time I want to employ this algorithm, to just write it once in an abstraction, to abstract it away under something that's simple for me to remember and use, rather than having to remember to plug in everything in the right place. Let's see, let's just run this real quick. So 624 to 540. Oh, and I totally messed up. See? I totally messed this up in earnest. This is a good old-fashioned honest mistake. And I have to fix that mistake in 4 places now, which luckily I know how to do easily, but sometimes it's not that easy. Okay, so that's the right answer. Okay, so that's a lot. So it'd be nice if I could just do this once. So let's look at that really quick. Let me just copy all this out. So if I were going to abstract this, I would probably call it factorial, def factorial. In fact, I would definitely call it factorial. We'll just say it takes in something called that it's going to call n, and I'll say prod equals 1 for I in range 2 to n plus 1. Prod times gets I return prod. And I know there's a bit going on there, but now every time I want to do factorial, I can just print factorial of let's do this, n equals 4, and we'll print factorial of n. And I could do actually I could just do it, I could call it n every time here, and just set it with different values, but we'll kind of mimic what we had. MNOP, M was 5, O was 3, and this was 8, and we'll do M O P. So now this, every time I want to use a factorial, it's nice and simple. And I don't even need this variable here. I actually could just do, could just pass in the number just like that every single time. Same deal. So this is a nice simple interface, an abstraction, if you will, to this process. And you can see they do the same thing. So that's one example of an abstraction. This is called a function. This def factorial is called a function, and we'll start writing those kind of at the end of this week or at the beginning of next week. The other type of abstraction, so we got functions. The other type of abstraction is variables, which we're going to be talking about today. And you probably saw me use, we talked about variables yesterday. You saw me use a couple variables in here, and that's actually a type of abstraction too. I think you could say it's an objectively simpler type, but it's still a type of abstraction. And if you think about it, right, like, you know, 8 is this data, and I abstract the data away behind the abstraction P, for example. That would be why it's an abstraction. So functions and variables, those are the two major types of abstractions that we're going to use. Let's see, oops. So the next major topic is going to be control flow, which hopefully we're going to have time to get into a little bit today. And finally, we've got iteration. And that's it. So you've just got to know your data types. You got to know your abstractions. One of those abstractions is variables, and you know, there's really not much going on there. There's a little bit, but not much. Functions might seem complicated, but I assure you, you know, once you practice them a little bit, they are very manageable. Control flow, this is going to allow us to write code that executes under certain conditions. So when we check a condition and it's true, it'll execute some certain code. If it's false, it'll execute other code, or it won't execute any code. So control flow lets us write dynamic code that responds to different situations differently. And iteration allows us to repeat processes a controlled number of times, or an arbitrary number of times potentially. Oops, let me get a little light in here. Apologies. I'm getting a desk lamp. My old one burnt out, and the bulb is like a really weird, tiny, expensive bulb, and it's the second one I bought like this year, so I'm just getting a different lamp. So sorry about the lighting situation. Okay. Cool. So just basically these 4 categories, just data types, abstractions. You're going to want to know control flow because obviously you want your program to respond differently to different situations. And you're going to want to know iteration so you can repeat processes dynamically without having, again, without having to just like write the same code a certain number of times. You know, one process might need you to repeat something 10 times, another process might need you to repeat something 4 times, and you know, because of that, you can't go in and change your code to have lines repeated 4 times and lines repeated 10 times every time you want to change the number of times something runs. So we have iteration structures or repetition. You can think about them as repetition structures, structures that will allow us to repeat operations based on however many times we tell it to. So one thing I want to explore a little more is data types, and I'm going to leave these unexplored for now. We'll get into talking more about those later. So the data types that we've covered int, float, bool. We talked about strings briefly. There's another type that we're going to talk about right now, which is none. Let's see here. Okay. So integers, pretty straightforward. These are positive or negative whole number values. Integers do not have fractional components to them. They do not have a decimal value to them. Floating point numbers are capable of expressing numeric values that have fractional components or that have a decimal value. The reason we don't call them decimal point numbers is because, as I'm sure you all know, computers operate on a base 2 system called binary. I'm going to say most human beings think best in base 10. I think that's a fairly safe assumption to make at this point, at this stage in human history. So if you try to like analyze those two bases against each other, there are no good numbers there are no numbers that are easy to express in both or that are round in both bases, basically. So a number like 64 is round in base 2, but it's not very round in base 10, you know. So things like that. So we want to frame things. Often we try to frame things in a base neutral way. So you can have a number with a pointed value that isn't a decimal number, because decimal means base 10. So we use the word float to mean a number with a fractional value expressed as a point value, and it could be in any base. Now, when we express numbers in Python, we always use base 10. So just expect to use base 10, and that will work as you expect it to. Booleans are pretty straightforward. Oops, I'm sorry. I missed something with floats, something that I wanted to cover with floats. So floats, there's an odd thing that can happen, and the reasons for this are fairly complicated, so I'm not going to go into the full explanation of this at the moment. It's not important to know necessarily how it works, just that it happens. There's something called underflow. And it's not a super common thing to cause problems, but it can cause problems if you are working on a problem where you need to express a very, very precise floating point number. Say, you know, it needs to be like, you know, the decimal places need to go out like, you know, 20 or 40 or 100 places. Your computer is what's called a finite precision machine. So there is a point at which your computer just is physically less and less capable of representing a more and more precise number. There are kind of ways to work around that, but essentially they involve like building other custom data types that do exist. People have built those types, and you can get extra large floating point number types from third-party libraries and things like that. But the built-in float is not that precise. It will not represent a super long precise floating point number. So if you try to do that, if you try to represent a number that's extremely precise, it'll give you or it'll cause an underflow. So let's look at an underflow really quick. So float underflow. So if I do print let's say 1 over, let's do this. So you can see, let's just try this. 1 over 23, let's try that. So I've got this right now. So I've got this pretty precise, pretty specific number that is a really good approximation of what 1 over 23 is. It's probably not exact because, you know, we might be able to calculate this much further out, but it's only going to give me this much, right? So if let's do a few more generations of this. Let's have something like that. Okay. So you can see, I'm not going to bother pasting those in there. You can see at some point I'm going to start to get this E notation in here, and it's going to kind of change the way this looks. This is not the underflow error yet. But it will, I just wanted to bring this up because it'll start kind of changing the way that floating point number looks. But if I do something really precise here, oh, this is actually not a good way to look at this. Let's do something like this. I may have done this. Oh, okay. I did this in a silly way. Let's do this. Let me just paste this one in just like that. Okay. Sorry about that. That got a little out of hand. So we look at this, you're going to see that it stops at some point. So here it'll do 1e minus 100, right? But at some point, it's just going to give me 0. So I've asked the machine to do more to represent a number that's so precise that it's not rounding this to 0 out of a sense of convenience. My CPU is just literally not capable of making a calculation that is this precise. So there is a limitation to what floats can do. It is not common that this limitation causes you problems. It can cause you problems, but it really doesn't happen that much. The reason we mention it is it's good to know if you encounter a problem with this, you'll know that it exists, and you will have at least heard about it before, so you can work with it from there. Cool. So that's floating point numbers. So you got to remember underflow is something that can happen. Booleans. So remember we talked about casting. So there's this thing in Python and a lot of other programming languages where Boolean values are true and false. They just have the two values, just true or false. But other data types can be considered can have states that are considered truthy or other states that are considered falsy, right? So if let's do this. If I try to cast, the best way to see this, if you're curious if some other data type, if some other value from another data type that's not a Boolean, if you're curious if it's truthy or falsy, just use the bool function and print it out. So let's say 3 is 3 truthy or falsy. So this is integer, an integer, right? So 3 is truthy. Let's check out 1. Is 1 truthy? Yes, 1 is truthy. How about 0? 0 is falsy. Okay, so maybe numbers with 0 in them are falsy, so maybe we should try 10. That's truthy though, right? Well, maybe there has to be more zeros in it. Let's try 100. And that's truthy as well, right? So just looking at this, right, you can say, so evidently, all the positive integers that I've tried are truthy, and the only falsy value we got was 0. Maybe negative integers would be different. So if I made these all negative, of course we can't really have negative 0, we'll just try these. And you can see these are actually all truthy as well. So you can kind of experiment around, try out different values like this. I am framing this like I'm curious to see what's truthy and what's falsy, but I do happen to know that 0 is falsy, and values that are not 0, integer values that are not 0, and this is exactly the same for floats as well, actually, are truthy, right? So whether a number is positive or negative, it's truthy. The only falsy value is 0. There's only one. So yeah, let's just do -3 here. And let's just prove this with floats as well. I know, probably some among you are wondering, yeah, but well, what if I have a floating point number? Let's just do the easy ones. 3.3. What if I have a floating point number that's like really small? Like if I have 0.00000000001. It's hard to see now. So let's just look at this. So that's truthy, right? This value, it's really small, but it is objectively not 0. It does have a value that is not equal to 0. So it's truthy, right? So this can be said about about integers and floats. 0 is falsy, and all other non-zero values for integers and floats are truthy. We talked about strings a little bit. So let's cast a string as a bool. So this might look like I've done something wrong, right? Like I have the quotes for a string, but I didn't actually pass anything into it. But this is fine. This is called an empty string. Big surprise there. It's a totally legal string. There's a lot of times where you use a totally empty string. It's just a string with no contents in it, but it's still a string. It just doesn't have any characters in it. And in this case, this empty string is falsy. If there's any contents in the string whatsoever, it's truthy, right? Even if those contents are kind of confusing, right? Even if the contents are false, right? This is the string of the word false, the false. you'd think, oh, maybe that's falsy, but no, the string of false is truthy because it's a string that's not empty. So any non-empty string is truthy, any empty string is falsy. You'll see when we get into other strings are kind of a what we might call a sequence type or a collection type. The same rule is true for any other of the other sequence types or collection types. If it's empty, it's falsy. If there's anything in it whatsoever, it doesn't matter what it is, then it's truthy. So truthiness and falsiness. Truthiness and falsiness. We talked about strings a little bit. Concatenation. So there's something you can do with strings called concatenation. It's really a big fancy word for adding two strings together. And it's so much like adding that we use the plus operator to do it. So the plus operator, when used with numbers, let's say 3 plus 4, it's called the plus operator. Excuse me, let me get my lights here, sorry. So when we use it with numbers, it's called the addition operator or the plus operator, plus symbol. When we use it with strings or other sequence types that support this, and a lot of other sequence types do support this behavior, other than strings, we call it concatenation. So if I say, let's do this with a couple of variables. I'm going to say A equals the string hello, and I'll just print A plus the string world. And I'll just to prove that these are separate strings, I'm going to print A before, and we'll print it after. Or actually, I'll comment out the after there. So you can see, so I declare the variable A with the value hello, the string value hello. I print off A and I get hello, and then I print A plus world and I get hello world. But notice it's one word. It's not going to assume a space in there. It's not going to assume that I wanted a space. If I want a space, I have to concatenate a space in there, just like that. Or I could just put it, as at the beginning of one of the words or the end of the other word or something. So yeah, so this is called concatenation. But usually when I'm reading this, I'll just say like, yeah, add those two strings together. Technically that's incorrect, but everybody knows what you mean. I'm not going to pick that nit. Not that people won't, but I personally, don't care if you call it adding strings or concatenating strings, but just know technically it is called concatenating strings. So here's a quick let's do a little mini breakout, and I apologize because I see a few questions in here, and I'll take those over this mini breakout. So the mini breakout is, what's this line going to print? So let's look at the behavior here. Declared A with hello, we printed off A, we concatenated A plus space plus hello world together. So what's the value of A? Is it going to be the original value? Or is it going to be the value that was the result of the concatenation? Oh, dang it. Original value is just hello. Sorry, original value is just this. Sorry, I didn't make that really clear. Cool. Looks like you all got it. I always do this thing where I'm like, haha, I'm gonna get them, and then I ask, and everybody's like, no, we understand. So nicely done. You foiled me. I'm not upset about it at all. Cool. So you can see this concatenation operation doesn't doesn't change the value of A. It just tells me, hey, what would it look like if I concatenated A and an empty, or excuse me, A and a string with a space in it, and the string world. If I concatenated those together, what would that string be? And that string would be hello world, right? I could even do something like B equals A plus space plus world, and then just do B. Oops. I guess I could just print hello world if I really wanted to, but cool. So remember when I gave you the counter example? I said counter equals 0. What happened, or if I say counter plus gets 1 and I print counter, what's the value of counter on this line 71? Right. Cool. Looks like everybody's got that one. So who, as an aside, or as a related question, this is syntactic sugar. Who remembers what this turns into? Write the line of code that this would turn into. What, in other words, what is this syntactic sugar for? What is this short for? Cool. Great. Yeah. Y'all got it, right? So this sort of recompiles under the hood as counter equals counter plus 1, like that. This is a conversation about strings. Why am I talking about counters? Well, I'm using the plus operator. Perhaps you can infer. So remember when I said we use empty strings, and a lot of times we do, in a similar way that we use 0 with a counter. If I want to count the number of recurrences of something, I might start a counter at 0 and then check conditions and see if I have an occurrence that I want to count, and then increment my counter according to the conditions that I check. Likewise, I might want to collect words or sentences or characters under certain conditions, whatever, into an empty string. So I might start an empty string, and using concatenation, I can say something like A plus gets hello. So what might the value, if I print A here, what might the value of A be? Yeah. Cool. Let's add another one. So now what's the value of A? Cool. Okay. We got a little thing going on with, does it have a space in it or not? That's interesting. So yeah, okay. So yes or no, will A have a space in it or not? Okay, cool. Yeah, and that's because I included that space right there. So hello world, right? So I can accumulate, let's say hello there world. I can accumulate answers into here, and just like this sort of counter thing, this is syntactic sugar for the very same thing. It's just concatenation instead of mathematical addition, right? So this is the very same thing. And just it has the same limitation that we need to initialize it with a flat regular equals somewhere first before we start doing other stuff with it. Okay, cool. So that's concatenation in a nutshell. And that's something that'll come up that'll be very useful to remember. So this is, sometimes I cover topics like, like underflow, where I'm like, you need to know this exists, but, if you forget about it, it's not a huge deal. Concatenation is something that you're going to use all the time. So definitely this is something to kind of emphasize and remember. All right. The none data type. Let's talk about none real quick. So none, you have Boolean values that have true and false, that just have the two values, and none is the only unary value type, meaning it only has one value. Can you guess? The value is print none. None is the value. It is the name of the type, and it is also the value. It's just none. And it is a data type that is not the other data types. That is literally its purpose. It is a data type that has a value of none that isn't any of the other data types. So sometimes you want to start a variable, or and you get into object-oriented programming, you kind of call them properties or attributes, and they're similar to variables. And sometimes you don't necessarily know what type it is going to end up being. Maybe there's certain scenarios where it'll be a string, and certain other scenarios where it'll be a float. Maybe you know what data type it's going to be, but you don't necessarily want to start it with a given value. You just want to start it at something neutral. So you might start it, you might initialize that property or that variable at one, or excuse me, at none, as sort of a neutral starting place. The real reason that it's important to know about none is, has anybody tried to print? So I printed a print of hello. So I'm printing hello here, and I'm passing my print into print. And notice I get hello, which is from this print, and none, which is from this print, right? So let's do hello is that string, and then we'll say print has the value of none, right? So it's kind of weird because it might feel like, well, print has the value of it printing something out to the console. Printing something out to the console is an action. It's a thing. It's an action that was taken. It's not a value. It's just something that happened, right? So functions that don't have a return, every single function in Python has to return something. If you don't specify a return, it automatically just returns none. So this is why none is important to know about. If you're writing a function and you're trying to use it somewhere and you get an error that says none type object can't do this, or none has no attribute, whatever, or you're looking at the result and you're expecting to see one thing but you're seeing none, it's probably because you forgot to put in a return, an explicit output into your function. So none is sometimes something you'll use, often it's something that you'll just see kind of automatically happening. Okay, cool. Well, I can't believe it, but we are at our halfway point already. This is a good place for a brief intermission. I'll put 5 minutes on the clock. Let's just reconvene at 7 minutes after the hour. Oh, and I see some, well, I'll take questions after we reconvene, sorry. Apologies if I've left you hanging with questions. We'll open up for questions after the break. Okay, and we're back. So let's open up for questions. I know I asked for like a bunch of breakouts, and I think there were questions above those breakouts. Rather than me trying to like crawl through and search for those, if your question was unanswered and you wanted answered, please repost it. For now, I see something regarding none and null, and I want to address this. Somebody's asking, is none different from null? Different languages, this value, the unary not value is a thing in, I think every language that I know. There are languages that don't have it. Most other languages call it null, N-U-L, or N-U-L-L. JavaScript in true form has two different none-like values. There's null with two L's, I believe, and there's undefined. And undefined in JavaScript can be written to a space by the JavaScript interpreter itself. Null cannot, but you can assign something a value of null or undefined yourself. But they are essentially the same thing when it comes down to it. They function in exactly the same way. It's just one can be assigned by the interpreter and the other can't. So Python only has one not value, and it's called none. Python does not have an undefined. There's nothing called undefined in Python. There's nothing called null in Python. I'll show you. Show you how to prove that. I'm not sure if that's what's being discussed there. I'm not sure exactly how to interpret that, but I just wanted to make clear, just to avoid any misunderstanding. So I'll show you how to prove that. So if I try to print none, it's going to print none. If I try to print undefined, I think I spelled that correctly. It's going to say name undefined is not defined. Okay. That's great. I didn't know that it would be that funny, but it is. Who knew that I would even find that funny in the first place? But I find that hilarious. Okay. So name undefined is not defined. So this is not a value. This is an error, right? This is just Python's looking at this and expecting a variable called, or maybe a function, or it's expecting an object in memory with the name of undefined. And since it doesn't see it, it doesn't know what to do. Oops. And let me find something. Oh, apologies. I just want to check on something. Oh, I just lost my OBS window briefly, and I want to make sure I didn't close it by accident. Okay, we're good. So undefined, it's just expecting something called undefined, and it just doesn't find it, so it's not there. Null, N-U-L, you can see we're going to get the same thing. Name null is not defined, so name null. And we're going to get the same thing if we try to do null with two L's. So the only not value in Python is none, N-O-N-E. But if you're familiar with another programming language, you might be familiar with undefined or null or nil. I think, what is it, Ruby that uses nil? There's a few use NIL. But it's the same thing. If you're familiar with the concepts and like how and why you would use those, same deal in Python. Non-highlighted, when you put it in, does that make it a method? You mean when I type it in, it highlights differently? It just means, in this case, it means Python recognizes it as something special. This syntax highlighting that I'm using here is a little bit weird. I actually usually use a custom syntax highlighting that I wrote, but I don't have that installed on this machine at the moment. It's kind of funny to me because it highlights built-in variables and it highlights built-in functions and user-created variables as white, which is really strange to me. But in general, if something is built into Python, your highlighting will catch it and kind of make it a different color. So you'll notice it changes color as I'm typing N-O-N-E, and that's the syntax highlighter going, oh, I know what that is. That's the none value. You'll see the same thing if I do T-R-U-E, right? So this orange highlighting is telling me that it's a value. And then with false, I get a different color for numbers, but it still gives me a color, right? I get yellow for strings. I'm going to get red for keywords. Oh, del, right? I don't know why del for some reason highlights blue, but I don't know. Maybe there's a good reason for that. You'll see I'll get red for operators and most keywords. So yeah, that's a good thing to pay attention to actually. I usually don't mention it, but pay attention to your syntax highlighting. If something looks off, something might be off, right? Like if I leave this quotation mark off, you can see this doesn't really look right. I'm expecting this to be a string. Same thing with that, So that's something to pay attention to. All right, cool. Anybody got one more question they really want to ask? Last call. Wait till the top of the minute. We've got 20 seconds if you want to put it in a question. Okay. If you do have questions, feel free to pop them in. I've been kind of trying to fly through this as fast as possible. So sorry if I've left you hanging. I will try to take them as we go, if at all possible. If it is possible for me to do that in a timely manner, I will. Okay. Cool. Well, let's actually dig into the material then, the actual material slated for today. So, variables. Let's get into variables a little more. Obviously, I've been using variables throughout this. We covered them. We basically covered them in the last class. But yeah, we'll just kind of reiterate that a little bit. So there's not terribly much to a variable. There's a variable has an identifier, the assignment operator, and the value. So the assignment operator just says we're making a variable, right? The identifier is specifically the name portion of the variable. Usually when we're talking about variables, we just call them variables. But if we want to refer to just the name part and be specific, no, I'm not talking about the whole variable as a thing, which is a name that's a pointer that points to an object in memory. I'm just talking about just the name part. You can use the term identifier. So an example of a variable is A, which is our identifier. Then we have our assignment operator, which is a single equals sign. A gets, and then some value, 10. Pretty straightforward. Just if you're curious, it doesn't work the other way. I can't say, you know, if I'm doing like math on paper, the statement or the the phrase a equals 10 and 10 equals a are equally valid, right? These are in other words, these are equality equal to each other. Not in Python. We can't say 10 equals a. That's not acceptable. That's a syntax error. There's no case where this is valid. So syntax error. Cannot assign to a literal. So 10 is a literal value. I am literally typing the value 10. And I'm trying to assign I'm trying to assign the thing to 10 so that 10 would point to a, which is actually not even defined here. So can't do it that way. We have to have the identifier on the left when we create a variable. Now, when we go to use the variable, so this is creating a variable. When we go to use the variable, we just say, put in the identifier part. We just put in the variable name, and we're off to the races. We can use it how and wherever we want. And wherever we use it, it will be treated as whatever value was assigned to it. Cool. So I guess just to really drive that home, we'll print a. A is equal to 10 there. So, I mean, shouldn't be any surprise that when we print a, we get 10. And 10 is a number. I can do math with numbers, so let's just multiply 10 by 3. And 10 times 3 is 30. So that's easy. This is nice when you want to perform some operation and reuse the result of that operation. You perform an operation once, and then whatever that operation produced, you can capture that product in a variable and then just reuse whatever that value is wherever you need it. And that brings me kind of back to abstraction, right? Like, rather than having to do, maybe you have a complicated formula, and rather than having to do the complicated formula every time, you capture it once, and then you abstract the result of that formula under the variable name, and then it's kind of easier to use it. Cool, so declaring variables. Variables are assigned using the equality operator, we already went through that. So there's some, everything I just went over is, I'm just gonna go ahead and say it, it's the important stuff about variables. There are some additional things that are maybe important later, more important later. For now, you don't need to worry about what I'm gonna show you too much. I do want you to see it, but you don't need to worry about this too much. You can declare multiple variables on one line. Let's say x comma y equals 3 comma 5. And then if I print x and y, we'll get 3 and 5. So what I don't want you to do, and particularly what I want you to avoid, is like this is kind of neat. It can don't do this as out of a matter of principle. If you have 3 or 4 variables to create somewhere, don't just cram them into one line because you think it's better to do it that way. It generally, like in this case, I mean, x and y, like maybe these are Cartesian coordinates. Maybe it might really make sense to do it this way. That might be fine, but since these are potentially related, I think I would still probably prefer to just do them on separate lines though. Just like that. This is not unreadable at all. Let's just do this. It's just straightforward, so. So I'll say do this generally. Do this over this. It's not like there's never a place to do this. There are times where this will kind of make more sense once we kind of get deeper, maybe mid or end of week 2. It'll become clear that there's a little bit something else going on here. But I just want you to see it for now, just because you will see it out there. So this is how I can assign 2 variables essentially on one line. There's another thing that you can do, and if I have multiple variables that I want to initialize all to the same number, I could say x, comma y, comma z equals 0, comma 0, comma 0, or I could say x equals y equals z equals 0. And the result, print x, y, z, the result is the same either way. So these 2 lines are essentially equivalent to each other. These are both kind of just, I don't know if it's right to call these syntactic sugar, but they're, I don't know, they make something a little, potentially a little nicer. I don't think that these are actually better patterns than just literally doing this on their own lines. So this is fine, and again, I would say this is simple. It keeps things like consistent. It keeps each line small and readable. We're not appealing to anything fancy to just like do a simple assignment. So 3 assignments on 3 lines, to me, whatever. So this is fine. You will see these as you get more advanced in Python. There will be moments where it will kind of make sense to do this, but I would just say you don't need to worry about it at all right now, but know they exist. All right. Let's see. Okay. So, naming variables. I mentioned this briefly. I'll just read through this. You should strive to give your variables well-defined, succinct names that describe what the kind of information that variable holds. I think there's a balance. There are different philosophies on this. The old school philosophy was to use variable names that were as short as possible. You'll see a lot of old C code, especially like Fortran and Pascal. Even at times when that wasn't necessary, people from like old school, the prior generation, or maybe 2 prior generations at this point of computer scientists ago, or maybe 3, I guess, were kind of schooled in this, like using super short variable names. The reason is punch card programming. Back in the days of punch card programming in the 70s, 60s and 70s, I guess even through the 80s, a punch card was only 80 columns long. It was 80 characters wide. So space was precious, right? There was literally no room to write super expressive code. So there was a pretty strong incentive. There were ways to work around it. If you needed to make a line that was longer than 80 characters, you could do it, but it was a pain, and the convention was to try to avoid it whenever possible. So using shorter variable names made a lot of sense. Well, I mean, this is not a punch card. If you haven't noticed, I can write a variable name, like this could be my variable name. Well, I can't have a semicolon in there, but I could do this. This could be my variable name if I wanted it to be. No, obviously, maybe naming something that's not just nonsense, naming a variable that's this long is probably bad practice for other reasons. But there's sort of a new school of thought of like using full words to, and maybe even naming a variable a short sentence. So you might, if you if I had some data type that I could describe as like list of clients who deferred service. This is in a pretty dang long variable name, but in the sort of the new school, maybe this is even a little bit on the long side. Maybe I would, shorten that a little bit, but in the new school kind of way of thinking, you will encounter this idea of like using full, long names that are very expressive and give you a very clear idea of what kind of data that's holding. And of course, like this would actually be like a different data structure here. But yeah, that might be a legitimate variable name. I like to kind of strike a balance. So what I do is I try to like look for patterns, like things that I'm naming often, and I develop my own shorthand, and I try to keep my shorthand basically obvious, right? So if I were naming, let's say we're doing something and I had to name a similar variable, I might call it clients deferred list, right? Now I've lost a little bit of meaning here. This up here says that the client's deferred service or something. Maybe there's some other way to interpret deferral. But if it's descriptive enough, it's maybe unlikely that it would get confused with something else. Then I would be perfectly happy calling it something like this that's a little bit shorter. And I might even find a way to shorten it further. So I try to find a balance of clear but succinct. So there are different schools of thought on this. I don't have anything really against other schools of thought on this, other than really try not to use single letter variable names unless there's a standing convention that makes it obvious what that would be, right? And if you're doing something that's like purely mathematical and clearly mathematical, and there's a convention around calling something n or k or p, then fine. If you're doing Cartesian coordinates, x, y, and z, it makes a lot of sense. But don't use single letter variable names out of principle. That's the only kind of thing that I would say to avoid in general. Okay, cool. This is an important point. There are some reserved words that can't be used as variable names. There are also some built-in things in Python that can be used as variable names, but you shouldn't use them. I'll give you an example. Print right? Print is this function that I keep using that makes everything that I do visible on my console. I could totally call a variable print. What's going to happen when I try to print? Anybody know? Go ahead and put it in Slack if you know. Looks like we have a question here too. Not sure if it's an issue on my end, but the video has been dropping off a number of times. Oh, shoot. Apologies for that. Hopefully it's gonna stay all right. Do let me know if there are video issues. I appreciate you letting me know because, you know, if it's something with my internet, I need to know so I can fix it as soon as possible. But it seems like people are okay. It might be you. Sorry. Okay. Cool. So back to this question, you know, what if I assign this is totally valid, right? Like if I run this, totally valid, totally okay to do this. I so strongly and deeply passionately wish this was an error, that Python would just be like, you can't call a variable print. That's a thing that already exists. You can't override print. What are you doing? And I wish I wish the error would be like a what are you doing error. Like, what do you think you're doing? Anyways, no, I guess it's a mistake that you could make in earnest. So, but if I try to print out print, I get a type error, right? Because it's trying to call this integer, it's trying to use this integer 5 as a function, and it's like, Python's like, I can't use an integer as a function. That's basically what this is saying. So it says int object is not callable. So print is gone. It's just gone from my program. It went away. It's poof. There's no print. I overwrote it. Now I only overwrote it for that. It's not like gone from my computer. I don't have to like reinstall Python. I didn't break anything permanently, but this code is silly and it's not gonna, you know, I can't use the print function anymore. So anytime you learn a function that's built in, you must not use it as a variable name. Python will let you, but you mustn't do it. You must try to remember which functions that you've learned and not use them as variable names, because you'll just totally override them, and Python will just be like, oh yeah, you didn't, I guess you didn't need that. It'll let you do it. But there is, let's see if I can actually do this. Let me copy this link really quick. Here is a link to a list of identifiers that you can't use, that it actually will yell at you if you try to use. All right, so 4 is one. Syntax error, invalid syntax. It's just like, nope. If is another. Else is another. And there's a bunch more. So there's, if you get this syntax error and it's pointing at one of your variable names, you might have named it something that's reserved. Just maybe give it, you know, a different name, LC, and it'll work fine. And just to prove I didn't break Python forever, you know, print works fine now that I don't have a variable called print. So I remember thinking about that, like when I was very first learning, when people say, oh, you overwrote that function, and I'm like, did I like break my Python install forever? It doesn't overwrite it like globally everywhere. It means in that run of the program, it thinks print means this variable rather than the function that's already defined. So you just rename the variable and everything's fine. No issues. Oops. Let's see if I can hit the right shortcut this time. There we go. Built-in function print error. Okay, cool. Seems like everybody's doing good. Boolean operations. we already looked at one of these, which is the equality operator. The equality operator is, sometimes I'll call these comparison operators. They're called Boolean operators because they evaluate to a Boolean value. I like to think about them as comparison operators because they compare things with each other. And a comparison can either be, that comparison, depending on what it is, can either be true or false, right? Something, A either is greater than B or it's not. It's either true that A is greater than B or it's false, right? If the operands are A and B. So let's look at each of these. So let's just do A and B. Why not? A and B, or A. We'll say A equals 9 and B equals 2. So let's say print A equals B. That's going to be false because 9 and 2 aren't equal. So if I do A equals 9, that's going to be true. But let's also check this one. So I can do the opposite operation with exclamation point equals, which is inequality, right? So equal is equality, exclamation point equal or bang equal. Sometimes you'll hear an exclamation mark called a bang. So bang equal means not equal. We'll just read this as A not equal to B, or A not equal to 9. So A not equal to B, is that true or false? This first line, go ahead and put it in Slack. True or false? A not equal to B. Is it going to be true or false? Seeing a lot of trues. You sure? You sure A is not equal to B? No, you're right. I'm just messing with you. It's true. So the expression A not equal to B is true, right? So we're using the inequality operator. So inequality is true when its operands are not equal, and it's false when they are equal. So it's false. The expression A not equal to 9 when A is 9 is like saying, is it true or false that 9 is not equal to 9? It's false because 9 is equal to 9. Okay, so with equality and inequality, I gave these examples using numbers. I'll give some examples using strings. With equality and inequality, we can check across types. We can check, yeah, basically we can do a lot with different types. The other ones are pretty much only useful for numbers, and you'll see why. So if I do, let's say, hello equal to world, and we'll do hello. Let's just do this. Boom, boom, boom. So what are these going to print? Hello equals world, hello equals hello, hello not equals world, hello not equal hello. What are each of those going to print? Go ahead and pop it in Slack. Cool. I made you do a little bit of typing there. So false, true, true, false. So we can use equality and inequality, right? Because a string can be equal to another string. It can be not equal to another string. Obviously, if it can be equal, it can be not equal. So it starts breaking down with greater than and lesser than. So if I say 3 greater than 4, 3, or let's try 4 greater than 4, and 5 greater than 4. What do you think this is going to give me? Same deal. What are these going to give me? Cool. Yeah. Let's run this real quick. So it's false, false, true. So the expression 3 is greater than 4 is false. 4 is greater than 4 is false. 5 is greater than 4 is true. We also have a variation on this, which is greater than or equal. So what's this one going to give me? Is it going to be the same? Is it going to be different? Great. So this one's going to give me false, true, true, right? Because so this middle case changed. So that middle case changed because with greater than or equal, obviously we're checking if it's also equal. And the same thing goes for, of course, we can do this whole thing with less than. Not capital M, excuse me, less than. There we go. So we can see if 3 is less than 4, 4 is less than 4, if 5 is less than 4, right? So I won't torture you. I won't make you put all these in. We'll just run it, right? So you can see 3 is less than 4. That's true. 4 is not less than 4. That's false. 5 is not less than 4, so that's also false. So these are just essentially going to be the opposites except for the equality part, right? So 3 is less than or equal to 4. That's true. 4 is less than or equal to 4. That's true. 5 is less than or equal to 4 is false. Cool. So what I was saying earlier, it kind of doesn't make sense. What, I mean, you might think of an answer to this question. sorry about the kind of stuttering there. I'm kind of thinking of a lot of thoughts all at once here. You might think of an answer to this question. What would it mean for hello to be greater than or less than goodbye? Right? This isn't this will work, but it's not an operation that we really use as much. So this is going to go off of the Unicode values within each of these characters. So it's gonna going to go off of, it's going to compare the literal ASCII numbers against each other. So you can see H comes after G in the alphabet, just like 5 comes after 4. So since 5 comes after 4 and 5 is greater, H comes after G, so H is greater. So this is not really something that we tend to use as much. So I'll just kind of leave that there. Like, you can do it, but it's not. It's kind of a case that you can more or less ignore. Cool. Logical operators. So these are the way. So these are the sort of the canonical terms for these in Python. These are called Boolean operators. These are called logical operators. If I were going to lay out this information in a way that made what I think more sense to me, I would call all of these Boolean operators because they all kind of concern Booleans and they all give back Booleans. And I would divide them into 2 classes. We have logical, which we're about to cover, and we just looked at comparison Boolean operators. So we looked at the comparison style Boolean operators, and now we're looking at the logical style Boolean operators. I'm kind of bending those terms a little bit out of what is canonical or what is canon in Python for those terms. So let's see. Here, I'll just pare that down actually. So logical operators, they still give back Boolean values, but their inputs are also Boolean values, right? So if I say not true, can you guess what not true is? Can you guess what not false is? I won't even make you do it in Slack. Right, so not true is going to be false, and not false is going to be true. Right, so these take Booleans as their arguments. Let's see what happens if I do something else. So remember how we talked about truthiness and falsiness, right? So 4 is a truthy value, 0 is a falsy value. So in this case, I can give it other data types. I know I kind of phrased that badly earlier. I was saying these take in Boolean values, but I should rephrase that to say these will work on other values, but they always treat them as if they were truthy or falsy. So they treat whatever their operands are as truthy or falsy values. So the way I think about them is I only ever use them directly on Boolean values themselves. In general, there's been some times where I've utilized like truthiness and falsiness to my advantage. More so to like do something in a certain way, just to say that I did it that way, but just to kind of like explore that way of doing it. In general, I try to avoid using truthiness and falsiness. I find that if your code kind of relies on truthy or falsy values, there are moments where that can be confusing. I'm not going to say you should never use it, but in general, I just try to keep my code, I try to keep my Booleans as Booleans. So that's not. We also have and or. So if you've ever studied formal logic, you'll be familiar with truth tables. So let's make some truth tables. So let's say true and true is, and we'll just do this. Oops. Okay. So and is only, so this expression expresses the value true when both of its inputs are true or truthy. Otherwise, it expresses the value false. Right? So true and true is true. False and true is false. True and false is false. False and false is false. So let's do another one for or. I love the bulk select. Or, okay, so true or true is true. False or true is also true. True or false is true. And false or false is false. So you can see we get this true, false, false, false for and true, 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 false for or. Some of you might be wondering like what the exclusive or is. It's kind of funny. An exclusive or is essentially the same system as are these two things different? So it happens that not equals kind of does that, right? So if you need an exclusive or, an XOR behavior, you can use not equals and you'll get the same result, which is going to be false, true XOR true is false, false XOR true is true, true XOR false is true, false XOR false is false. And it, like I said, it happens that, you know, inequality just happens to have the same truth table as XOR, so there's that. There is a bitwise, explicit bitwise exclusive OR operator. I'm not going to get into the bitwise operators. It's a whole can of worms. You can look them up yourself if you want to. We just don't really get into it in our material because it's not really pertinent to what we're doing. Cool. Wow, we are like right on the edge of time. This is going to go into the bitwise operators, just kind of mention some really quick. If you're curious, if you know what bitwise operations are, these are your bitwise logical operators. You have bitwise not, bitwise and, bitwise or, which is just vertical bar or pipe. And then bitwise exclusive or, which is the caret symbol. Somebody asked the other day, can you use super, or I always call that symbol caret. I don't know, I think there's a few different names for it, but can you use that for exponentiation? I actually wish that was exponentiation. That's what I'm more familiar with from like literally everything else, but it's not. It's exclusive or. It's bitwise exclusive or, excuse me. So yeah, if you know your bitwise, if you know what bitwise operations are, there they are. If not, just don't worry about it at all. So order of logical operations, they forgot non-exclusive or up here, but that's okay. It doesn't really matter because, like I said, I'm not really using it. So order of operations for logical operators is not followed by and followed by or, and that's worth remembering. It's not complicated, or excuse me, let me try that again. It's not common that you end up writing like really complicated lines with like nots and ors in there in one line, but it happens occasionally. I generally try to avoid that and try to break things up more. But the way you control it is the same way you control it with order of operations in math. You just put parentheses around the things that you want to evaluate first. Uh-oh. Can people give me a thumbs up in Slack if you can hear me? Oh no. Oh, interesting. Okay. I am experiencing a pretty serious glitch on my end. My machine is actually in the middle of a crash, unfortunately. I'm glad you can hear me. I have mouse control, but I can't actually see what's going on my screen. Um, that's unfortunate. I think OBS kind of has this persistent glitch. There's an echoey reverb on my audio. Okay. Well, this is a good time for this to happen. We've only got a couple minutes left in class, and this is a great stopping point. I'm going to wrap things up here. I'm going to have to just end the Zoom meeting. If you want to stay on for questions, I will reconnect to the Zoom meeting and